Welcome. Today we will talk about CSS again, and I'm bringing a few topics for you. Let's talk about the stacking context. What does that mean? How does that work? We're going to talk about some CSS selectors. There's too many of them, so I'm not going to talk about every single one of them, but I'm going to talk about plenty of them, so you can achieve pretty much anything. We're going to talk about combining selectors for more CSS magic. So you're going to perform a lot of stuff with just CSS, where you thought possible would just be with JavaScript, for example. Then I'm going to talk about grid. And then I'm going to create a common layout that we have in many places, even at 3. We have layouts that we can create simply with just a few lines of CSS. So stacking context. Stacking context, you've probably seen this multiple times, is usually when components appear on top of each other. I'm going to say elements or nodes in relation to what an HTML element is in this talk. So stacking context is mainly having something on top of something else. Usually they share visibility. So if something it is not transparent, you can only see the thing that is on top. In the case of stacking books, you can only see the top book if you're looking at it from the top. So stacking context examples functions more or less like this. You have your x-axis, you have a y-axis, usually they're width and height. But in the viewport, that's what we see. But there's also the z-axis that we usually take control over that with just the z-index key. But there are other ways to make these contexts appear, right? And when I say this is stacking context, and things start getting a little bit more mathematic. So in the viewport, we only, like I said, we only see the 2D context, or most of the time you only see the 2D context, right? There's WebGL and a few other things that allow for 3D context. But we mainly see only the 2D context in a web page, and the z-axis becomes invisible to the user. So this visibility is relative to the user, right? And who brought us this relativity? All the way back to the same theory. I'm not kidding. It is the same thing. So the elements themselves, they are going to be the same position in relation to each other, but they are going to change in relation to the user, right? So this stacking context that we have in CSS is the answer to the relativity between elements and the user looking at that 2D viewport. The elements will be stacked, and they will move in relation to their siblings and the parent and the page. But what makes it tricky is that CSS has so many different layers, and sometimes there are different things that trigger this context. So you might think that if something has a higher z-index than something else, then that thing should appear on top. And it's not always the case, as we're going to see with a few examples later. So since multiple things can create a stacking context, it is you, the developer, has to understand the application we're working on as a whole, to understand all these contexts and think about how to pick up these layers and bring them into uniformity on the page. So I have some examples here. I'm going to start with one example that I prepared for you. I'm going to share the links in the talk as well. So if you want to follow along, or if you want to just see what I do, go ahead. So in this example, I have a design. The HTML is just 3 divs, one sibling of each other. And inside of each one of these divs, I have a span. And that's it for the layout. There's nothing else. And as you can see here, I'm adding some position absolute here. And adding position absolute makes them stackable. And since they are occupying some of the same space, the HTML that comes afterwards is placed on top. So this in itself, without even changing the z-index, already creates a stacking context. I have things on top of each other here. So you see, I'm going to change the z-index of the spans inside, not the divs, okay? So when I'm targeting these here, I'm targeting the spans here on this on this code here. So nurse, as you can see here, is behind the doctor, right? So if I add the index of 1 to it, and the page should update. So you see now there's on top, okay? And if I add the index 1 to this one, so doctor now has the same index of the other one. Okay, so they both share the same index, but there's another thing. The doctor is coming afterwards in HTML. So even if they have the same index, there's another thing adding this context to the div, right? So if I go here on my receptionist and do the index of 2, then what happens is this one comes on top of it because it has a higher index and is also placed afterwards. So I could put a z index of 3 in this one and 3 in this other one, and they will share the third position in the z index. But this one will be on top of the nurse because it comes afterwards in HTML. But this one comes afterwards in HTML but has a lower z index than the other one, right? So what happens is that, like, now you see there's two things that are changing this layer positioning. There's the z index property, and there's also the position of the HTML elements. But there are other things that also trigger it. I want to show you this. So now I'm targeting the divs, not the spans. Okay, so the div that is wrapping each one of these, the div is the z index of this div is auto. The default is auto, so there's no stacking context for these ones. So what happens if now nurse is behind the doctor, right? What happens if I add the index of 1 to it? Okay, so my CSS works in the way that I have a div, I span is inside of this div, and the span is the one that has this style. Okay, and I'm asking you what happens if I change the index of the div. You can take your own thoughts. I'm gonna release this, and what happens? Oh, it didn't happen anything. Okay, maybe something went wrong, right? But no, that's not the case. Actually, what is happening here is that the div itself, it is not adding a context in this case. The div is absolute, the span is absolute positioned, and the div has a height and a width of 0 because the elements inside of each one of this div is basically non-existent in relation to this div. Okay, but there are other things that can trigger this this change in CSS. So, for example, doctor here is on top of the nurse, right? So if I change it to opacity, you go behind it. Wow, right? I know. So opacity also creates this context, which is incredible. And not only opacity. So if we transform an element, when we do that all the time with animations, we also create this 3D context on the page. And elements that have not been transformed are not part of this are not part of this context. So bottom line, what I want you to take out of this is that if you go around and start adding Z index to a lot of stuff, and it's not working, but they feel like they share the same context. Sometimes they don't, because they might be sharing something like a transform, opacity. There's many other things that actually share. Let's go back. Let's see if I added this here. No, actually, no. But in the documentation, we have multiple things that actually add to this context. So if you have any of these properties being applied, you will create a 3D context as well. And this will make that these divs will move directions in the page. And sometimes not being able to put something on top of something else, that is the reason. If you have a model, for example, that should be on a higher Z index, but you are transforming with an animation to appear in a certain part of the page, that transformation could trigger the model to not appear where you expect it to be. So that is one of the reasons why this happens. Okay, so I hope you take something out of this. I'm going to move next to Selector so we don't stay here forever. So the way that we target things in CSS is with CSS selectors, right? Just like I did here, where I have my class name being targeting this specific wrapper and my spans being targeted with this specific class as well. There are many other selectors that we can use to target elements in the page. the page is a tree, basically, where when you target something on the page, you have to traverse the DOM, or in fact, you have to traverse the abstract syntax tree of the HTML to get into the element that you want to find. So if I add a class to an element and I want to target that specific element, my selector will work by trying to find where the element is on the page. And if I have multiple selectors, I will have to find multiple different things on the page as well. We're going to go to performance a little bit later. I'm going to speak a little bit more about it. And there's a question. Since you talk about potentially perform, or maybe I jumped a few things here. Let me see. Stacking context, and then I jump to select. I think I'm missing a few links. All right. Let me see if I added this here. Okay, let me go through a few selectors with you so I don't jump the horse too much, right? Perhaps it's later in the presentation, I didn't pay too much attention to it. So I'm hoping you know this, which is just element selectors. You're selecting a paragraph or select a class or select an ID. This is how we're doing most of the time. So you also have the universal selector, right? I prepared some HTML here so you can see some differences on how these things happen. So here I have my universal selector. I'm going to also share this document with you so you can try yourself if you want. So here, if I uncomment this property, what happens is that everything becomes with a background red, right? Or everything that doesn't have a higher specificity, because you see the background of this one did not become red. So it means that some things have higher specificity than this other selector. But this selector means select everything, right? So we also have the direct children selector, which is this sign, which is the greater than sign. So what happens, for example, if I select all the children that are inside of this direct children element, so I'm selecting all of these. If you take a look at the HTML, let's see, the direct children here, you have a paragraph that is direct children of this one, and you have another paragraph that is also direct children, but you have a div, and then inside of this div here, I have another paragraph. So this paragraph here, it is not a direct child of these direct children, right? So if I uncomment this line, we're going to see that these two become green, but this one keeps red because I'm still following this rule here. Okay, so this is what direct children means. And if you go to adjacent siblings, so adjacent sibling, it means I am going to target, let me row here, it keeps scrolling, so this is kind of annoying, but we're going to go through this. Okay, here. So the adjacent sibling, it will target all the elements that I have here. There's a box that has a sibling named a box, okay? So if inside of this section here, I have a box that the next element, the next sibling is also a box, then I'm targeting this one, okay? So in this case, if I uncomment this one, you see that I'm targeting this one and this one, but not this one or this one, because they need to have this one, and then the next, this one is going to be targeted, okay? So it's a little bit different with the general sibling, that is the difference. The general sibling doesn't really care what is in between. It just needs to know if I have any box that after this box, I also have another one, or whatever you want, right? It doesn't have to be a box. But if we uncomment this one, you see that it targets, even though this one is not direct sibling of this one, it still targets this one. So that is the difference if you were unsure. We also have a few pseudo-class selectors, and they are very interesting. So if we're targeting, for example, the first child, it literally means the first child that you're going to see here. So in this one, I have my first, and then I'm targeting the first child. So only span 1 is going to be targeted, okay? Now, if I target the last child, only the last one is going to be targeted. And this sometimes is interesting in design. For example, if we wanted to not the last item of a list to have the border right, for example, you can target that last item and remove the border right only from that one, for example. That is a way to do it. You also have this n-phase child and some mathematics inside. I know maths usually scares a little bit of people, but just think that this one's going to repeat every 2 elements, then it's going to add the next one. Okay, so what this does to me is that I'm going to target every second element and the next one of it. And it didn't work. Oh no, yeah, it actually updated here. I forgot to uncomment the previous CSS. Okay, so I'm targeting every second element, starting from the first one. And I can also target in this one in the same mathematics. So you can use math to help you, right? So targeting only the spans, there are children of this second child selector. But there are many ways where you can use mathematics to actually target the stuff that you want to target off in your page. And then you have other types of selectors. Maybe this would be too much for this talk. You can look at this one later, but there are like plenty of attribute selectors, anything child, that I want you to understand about. And a few of these target selectors here that I have, they match in interesting places. So if my element here has values, so now CSS is utilizing values, these ones, for example, to be able to target elements, right? So if my link is an HTTP, so I'm targeting these ones. If my ref, I don't know how you pronounce this, actually, just realized it. I say ref. If my ref has Google, I put a color black, for example, because these are links to Google. It doesn't really matter the output. But if their link ends in Canada, then I have the other option. So you can do a few things with this. Like you can imagine that how this could be useful in some cases. Especially nice if you're adding like download links and you want to add like a specific icon before. You can do that with just CSS as well. And this is one of my favorite ones. It's the not selector. So here, let me see what I find. Here, there you go. So here I have my not selector. So here I have just one, let's say one nav bar. This is becoming a bit too small, maybe. Let's see. Okay. So what I'm trying to do here is to add these separators here in between. But the way that I'm usually adding them is to add them to the border right element. Then the border right is going to be of a specific size and color, right? But what happens that then the last element is also going to have it. And then, like I said before, we can target the last child, for example, and I was remove the border from them. But what about we not even add it to begin with, right? You can do that with a not selector. So if I am doing here with the last child, for example, like we're doing here, I can do something like this, and then it appears here, right? So let me remove this border right here. And if I add the border with the not selector, then I can add the border to each one of these, but not the last one. And the way that this works is that I want to target every single list item that is not the last child. So I can just do this all in one line. Okay, so I am targeting every single list item here that is not the last child. So it's just everything else. It is interesting. You can use this in so many places. And we have a few new selectors in CSS that have been added earlier or late last year, actually. And the is and were selector. Usually in layouts, we have to do something like this. We have our selector, and then we want to have the hover for the paragraph, and everything seems like it has to have a hover, right? So you do something like this, and then that's usually how you write it. And then you have some hover effect here. That's great. It works. But if you want to simplify these things, and there's plenty of places where you want to simplify this stuff, you can just use the selector is, and inside of the is, you pass each one of these as parameters of this is selector. And now, if I target them like this, what's going to happen is that it works exactly the same way. So this code is exactly the same as this code. Well, not exactly the same. Is has a higher specificity than this. And the only difference from this and from is and were, or where, is that where ignores all specificity. So if there's anything else in the page that adds any sort of specificity, it overwrites this one. And in this case, it has a higher specificity. In specificity, I mean, if you declare a rule, then declare another rule afterwards, the rule that is the latest declared, they are going to override the previous one. That is how it usually works. Unless you add, for example, important to something, and then that thing becomes the one that shares the highest specificity. So this is what is actually happening in this context, right? Moving forward, we have has selector, which is a warning. Don't use it everywhere. It has only 85% support as of today, so it is not really something that you want to deliver to everyone. Perhaps if you can control what type of browser somebody uses, if you say, if you use Chrome, this is going to work to your specific clients, that's good. But unless you have that opportunity, I wouldn't use this in production today. It's more for like a personal things. It is really interesting. So has is the first time since beginning of CSS, and this is probably like 20 years now, that we have the possibility to target the parent element. Okay, how do we target the parent element in CSS? Up until today, there is no way. If you want to do something based on what happens inside of a div, and if something like that happens inside the div, you want to modify the div itself, you have to use JavaScript. Okay, today you have access to a has, and probably in the middle of the year, people will phase out this enough that you can use this in production, but not now. So I have better examples with has afterwards. But what I want you to take out of this one, I'm going to show you later. What I want to take you out of this one is that you can target the parent based on what happens in the child. Okay, so, and there's a few others that you can target. There's a length selector. I'm not sure if this is interesting to everyone. I think it's really interesting. So with the length selector, I can pass a language inside of each one of these. So English, French, and I don't dare to say this in their own languages. So if just by adding this, I can define how each one of these languages behave just based on the lang. It doesn't have any other types of selectors inside that do anything. This is just the language of the div. This is not even a class itself. So this is pretty interesting in terms of how you can target stuff to make more stuff happens, right? And I promise you a more advanced selector utilizing has. So I prepared some form of grid here with images. And what's happened here is like it's pretty concise CSS. You can render everything in one page here. So what I'm adding here, this is just some basic stuff, and the magic starts happening here. So here I'm just adding, saying that my image gallery, if my image gallery, which is the whole thing here, cool effect, if it has an image that has been hovered, I want all the images that have not been hovered to have this style. Plenty of stuff happening here, right? Using the not selector, we have the has selector, and you're making all this happen inside of the image itself. So the images here are receiving this style only when this gallery has an image that has been hovered. How can you target all of this, right? And in this one, I'm also targeting the images that have not been hovered and a specific type of children in this positioning. That's how you accomplish this movement back and forth. So just a few lines of CSS with the right selectors, you can achieve magic that you would otherwise need a little bit of JavaScript for this. Magic, I love this. Okay, so we are talking about selectors. That's nice, but there's also selectors performance. And the performance is something that in general, I would say, do not worry too much about it unless you find problems. As if with most stuff, don't worry too much about it unless you find problems. But whenever we select something, we have to traverse the HTML to find these changes. We have to traverse our documents to find these selections that we made, right? So does it matter? Okay, in general, it is fast. Okay, in general, it's very fast to target some things, but it depends also. So how many elements you have in your app? How often do you update your DOM? How is the specificity of each selector? This is important. And each selector has its own algorithmical performance that you might want to take into account. So in general, you can think about the HTML document as an unbalanced tree. And an unbalanced tree is just I'm thinking tree as in, it could be just any tree where you have nodes that branch out into other nodes and nodes, right? But in HTML, is common that you would see an element and having way more elements than others. You know, when you open the HTML to inspect it, and then you have to start clicking on divs and divs and divs until you reach out, and they have like cascading inside of each other. So this is usually what happens. And what happens with trees that are unbalanced is that they are trickier to have performant algorithms to find stuff inside of them. Okay, so that is one of the good reasons why selector performance and trying to make things a little bit more concise and not adding that extra div if you don't really need it. That's why it's important. So generally speaking, if you target something with directly just a class, that performs better than if you target something like this. If you don't really need this specificity, use the less specific one, always. That's a good rule of thumb. Whenever you don't need more specificity, just don't use it. Then you increase performance. By how much? I don't know. You have to measure it, right? The only answer is to measure it. But the thing that will happen is that if you search for this one, you are going to make your algorithm find every class in the page. And then as soon as it finds this answer, it's going to try to find, okay, let me look at every parent where this class has a parent that is an item. And let me look at every parent of this that is an li, every parent of this that is a ul. You know, it could be an ol or something else instead. So you have to perform all these algorithmical operations to get into saying, okay, I found this one. And if you use just this one, it's the first phase of this one. Okay, so we're looking at big O complexity again. Okay, so this could be represented by big O notation of n times k, which n is the number of entrances that you find times the amount of keys, the amount of elements that you're trying to find. If you want to know a little bit more about big O notation, I have a link here. But that's it for now. Oh, here's my lost slide that I should have done before. Great. Okay, let's see what else we lost here. Where are we? I hope you're following along. I know this is tricky, but we have space for questions afterwards. And let me talk a little bit about CSS grid. So with the display grid property, it feels like a lot is happening as soon as you add display grid. Not only the element that you are setting to display grid is changed to an actual grid, every direct child of that element will become a grid item as well. So when you see, for example, justify items, you are targeting actually grid items. That's what that means. With grid, you have more control. Okay, this is more like trying to understand what is grid and what is flexbox, and we have both. They both serve the same purposes. They are different. Okay, so with grid, you have more control over the entire layout, and you can define rules to the grid and how each of its children should behave. With flexbox, you generally define a layout, but each child in a flexbox layout has way more freedom to determine how they will behave in that flex flow. Okay, and that is especially true if you have flex wrap. So when you're flex wrapping stuff, it could be that some elements are not going to be right aligned the same way. They're going to occupy more space, even though you have flex one. It can become a mess. So if you're working with some things that you want more fine-grained control, grid is the answer to it. So I have a few examples here. I'm going to start with this one. Okay, let me copy from this one. I'm going to send here in the channel in case you want to follow along and play. So in here, I just have this layout here. This is just HTML element that has a div with a grid, and each one of these, each child of this grid is just a div with an item that is a number. Okay, that is all the HTML. So you're going to focus just on the CSS on this one. So here I have my direct child of the grid being this color. That's what's happening. That's mainly anything. And here I'm doing display grid and adding a gap. Okay, so I want this layout to become different, right? So we have a few options here. So I said we have more fine-grained control over a grid layout than we have over a flexbox layout when we want to define these rules. So one of the examples is we want to have a layout with 3 columns. One of them is 150 pixels, then 100 pixels, then 200 pixels, and we have them here. So I defined one column layout. So this layout is replicating throughout the rest of them. And this is called an implicit and explicit definition. The explicit one means I am explicitly saying that this is going to have a column of 150 pixels, 100 pixels, and 200 pixels. And the rest of the layout, the rows, are just following along. They are implicit. I did not have to tell them to behave in a certain way. They're behaving implicitly related to the explicitly definition on the first row. But let's say we want to have 100% width on this one. Like we want to apply the entire screen. How do we do that? Well, we can think about it certain ways, right? We can do 33%. This doesn't really count to 100, right? When you can put the last one to 34%, for example, but this is starting to create some sidebars here. This is not good, right? So yeah, maybe if we do some calculations here, and this should be better, right? 100% divided by 3, each one of them, not really getting the job done. So in grid, we have a new unit to work with, and the unit is FR. And FR is short for 1 fraction, I think, but nobody ever come up with something better, so it's going to be 1 fraction. So right now you see that it already fixes everything. So the problem with using percentages or sizes in grid is that you are not going to take into consideration everything else that the grid has. For example, the gap was not being taken into account into all this. When you put 100% in calculation for each one of the child, you are ignoring that there's a gap in between, or there could be something else as well. And you don't calculate for all that. We're going to be what, like 100% minus 5 pixels? This is going to get crazy at some point. So 1 fraction unit is what creates all this, right? So if you want, for example, a 12-column layout, you can also do that, and it calculates exactly how you want. And there's, of course, a better way than to write this 12 times. We have the repeat function. With repeat function, this is exactly the same thing. I'll comment this out just so you see that I'm not lying to you. So if I go back and do this one, it gets to the other layout, and this one applies 12 as well. And with this one, I'm just saying that I want this div to be of repeat 12 times, and I want to have 1 fraction unit. And there's many ways that you can achieve multiple different layouts. So here, for example, I said that I want to repeat an amount that fits. This is a new keyword, right? So out of fit, how does that work? It means that I want this layout to be full in relation to this other function. This function is called min max. So it's going to take a minimum value. So each one of these children here are going to have a minimum value of 150 pixels and a maximum value of 1 fraction. Okay, so if I start doing this, it just works on the page. It's 1 line. It is incredible how we can have fine control at the same time of simplicity. We don't have to write that many rules. I love this. Okay, so here we have rows defined implicitly, but let's explicitly define them. So let me define that I want my first row to be 120 pixels, the second 180, and the third is 60 pixels. Okay, so here I have these defined, but as you can see here, this is the implicit rows. So this is going to be just the implicitly defined based on the previously one. Okay, so how does this work is that if you do not explicitly define it, it's going to take the last one available. And you have a few things that you can do here. Let's say you want to center these things, right? How do you center this? So like I said before, each child of a grid is called grid item. And to target grid items, you can use, for example, justify items and center them, and align items and center them. And this is not exactly what you're expecting, right? You just wanted to center the numbers. How do you do that? Okay, there's a shorthand to achieve justify and align. It's place. Place is just the same thing as justify items and align items. Place items going to be the same thing. But the way to do that would be to maybe, let's say, I'm going to do place self-center. This I'm targeting each one of the divs now. I'm inside of the div themselves. I'm saying that they want to be centered. I still don't get the same thing. So perhaps, let's see, I'm going to add width 100% and height 100%. That's going to do it, right? We lost the gap. That is not how we should do it. So how should we do it? Well, if we want these to behave like grids, we can first tell them, hey, you are a grid, and I want the content. And now when you target the content, you have the node inside of the div. Okay, so the HTML elements, they are elements, but the text inside of them, they are called nodes. And these could be the contents that they have. So in this case, if I'm just the content to be centered, I can do it like this. Okay, it's a lot of keywords, but they are there and they are amazing. And yeah, that's how you achieve great designs. And what else can you do with this, right? So let's do a few interesting things here. So one thing that we can do is to move things around. So I am targeting my item to, as you remember from my HTML, each one of these receives a class. I'm targeting this one, okay, the one which has the 2 inside of it. And by targeting this one, I'm going to say, hey, I want the column start to be 1. Okay. Oh, it's starting this line here now. And I want the column end to be 4. Oh, it's occupying 4 spaces now, right? As you remember, this grid, now it has this function here that's going to fit into the screen. And it's going to be a minimum 150 pixels or 1 FR. So this is going to occupy 3 spaces, okay? Because I'm going to go from 1 to 4, I have 3. I can represent this also like this as a shorthand. This is a shorthand for these two. So these I'm occupying 2 spaces. And I also can change the column to be something else. So I can tell it start at column 3 and span 4 columns. So this means I want to take 4 spaces from this point, right? I can tell it I want it to start a row 2. And I want it to be this grid column 3 to 7. And I want the row to be 12. Oh, I don't have 12 rows, so what is happening here? This is the amount of gaps that I have in between. So if I put this row to be 122, it just goes down there, because this 120 times 5, I guess, because that's the amount of gap that I have. I also could do a grid column 1 and -1, and this will take the whole area. It takes everything in that column. So you can do plenty of designs with this. But when you're looking at more complex designs where you want to have more control over where things should appear, this is not my preference. My preference is to use grid areas. It's another keyword, right? You can do plenty with this navigation here, but when you're looking at a layout that we want to achieve for ourselves, we want to have some grid areas. And I can achieve this entire layout. Oh, that was some zoom. I can achieve this entire layout with just a few lines. And there's some magic here with CSS has. When were you able to open a sidebar with just CSS? There's no JavaScript here. I'm not lying to you. It's no JavaScript. 0, nada. Okay. So I'm opening and closing this, and even changing this label from open to close with just CSS. How do you do that? Huh? So the way that you do that is with some has selectors. Okay. And I'm changing these to have grid template areas. Grid template areas greatly help you achieve the design that you want. So I'm telling here that, let's take a look at this HTML here. I have a header. This is a body. I have a header. I also have my navigation, and I have my article. I have this A site, which is this beautiful form here that I copied from somebody. And then I have another, wait, this header should not supposed to be here, I guess. And then I have, okay, this is all, okay, this is the form that I had. Yeah, okay, so yeah, this is the form. All right, I forgot. This was inside of something else. I might have messed up this HTML for the demo, but it's fine. It's still working. And then I have my footer here at the end. Okay, and this all this design, all the positions of all these elements here are achieved with these lines of CSS. Okay, I can position them just by saying, hey, I want these areas to be header, 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 sidebar, content, and form, then footer, 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 which means header will occupy the full space. Then I'm going to have a sidebar on the left, content in the middle, form on the right, and then everything else here is going to be the footer. Then I'm going to say, just like in the other example, I'm going to say that my columns are going to be 80 pixels, 4 fractions, and then this min max here that's going to say, hey, I want to occupy minimum 375 pixels, but at maximum 1 FR. Okay, and what this will happen is that this will occupy the amount of space in the screen, but when this is not here, I am having this layout being set. So this layout doesn't have the form on the side, and this is what is creating this whole thing. So it is very simple to achieve a very complex design, I would say, that we see everywhere with just a few lines of code. And there's no confusion here. What happens if I want to change these things around, right? If I want to have my header down there and my footer up here, what happens? So I can just swap them around. And what happens if I want to have my sidebar on the middle? I can just swap them around. And now stop working, perhaps I added this space here, or stop it updating. But yeah, I have to select it. And it's a different one, it's not selected. So I can create so many designs and so many different things with just a few differences here. And there's not much that is happening. Everything is reacting to one single string. This is just one single label here that I'm changing everything from one thing to the other thing. Okay. Now, since you can control things like this, now with grid, you have more power to have control over how these things will behave, and you can even change them based on how your HTML is looking like. And you need 0 JavaScript to achieve all this. So yeah, that is kind of what I wanted to bring to you today. Do you have any questions? Thank you, Stephen. All right, I am going to stop the recording in case somebody has a question, but they don't want to appear. That's fine. Stop recording.